In the previous video, we discovered that not all zeros of polynomial functions can be found on the list of potential rational zeros. Sometimes, some zeros are irrational. We get irrational zeros when we cannot simplify square roots into rational numbers. Irrational numbers and rational numbers belong to a bigger group of numbers called real numbers. So far, the zeros we've been getting for polynomial functions are all real numbers. What are other possibilities about zeros of polynomial functions? Let's find the zeros of p of x and let's see what we're going to discover. I want you to pause this video so that you can find the zeros of p of x on a separate piece of paper. And when you're done, I want you to resume on watching the video. Did you find only two rational zeros? At this point, we are going to find the rest of the zeros by applying the quadratic formula. This is the value for A, this is the value for B, and this is the value for C. I want you to pause the video again so that you can find the zeros using the quadratic formula. Come back when you're done. Did you get something like this? But wait, what is the square root of negative 3? How does the graph look like if the zero has a square root of negative 3? Let's take a look. So I'm going to graph this function, p of x. Now let's put the axis. Now here it is. What do we notice? We notice that the two rational zeros are visible in the graph, but the zeros that has the square root of negative 3 are not visible in the graph. Probably that is the reason why mathematicians call square root of negative 3 imaginary numbers. So they said that, let me bring this over. Square root of negative 3 is imaginary. So let me write that down. Square root of negative 3 is the same as square root of negative 1 times square root of 3. Mathematicians defined square root of negative 1 as imaginary number, 1 unit of imaginary number. So this becomes like this, or you can write it as square root of 3i. Whenever we see square root of 3i or any number I, that means it's not visible in the rectangular coordinate system. So let's simplify this. This is going to be x equals 1 plus square root of 3i over 2, and the other one is 1 plus, no, not plus, but minus square root of 3i over 2. These are the two other zeros of the function. And the other two are 1 and negative 2. So we actually have 4 zeros also, but 2 of them are rationals and the 2 other zeros are imaginary.